Hi everybody. So yeah, I'm trying to give you a presentation on a little bit what's happening in the smart home market in general, and why OSGi is important in this domain, and what should be considerations to develop such a smart home system, and what are major building blocks to get it done right. So I start a little bit with smart home is on everybody's agenda. So really, everybody is doing something with smart home, around smart home. Smart home also became mainstream because of the growing interest in the Internet of Things in general. Consumers see the added value now also for smart home systems, and it's most importantly now also affordable. There are different kinds of studies on what is revenue for smart home systems and the install base. I picked only the ones I liked. So it's all looking positive, yeah. So Berg Insight says by 2017 we'll have 17 or almost 17.5 million installed smart home systems, revenue around 2.5 billion euro. Bitkom, which is the biggest IT association in Europe, I think, it's a German association, expects 1 million smart homes in Germany until 2020. And there are a lot more indications that smart home is taking off. One of them is that big corporates are now investing. You heard probably that Nest was bought by Google, 3 billion acquisition. Apple is investing in HomeKit and so on. Philips, is actually very successful with the Hue lamps, and other companies like Samsung, AT&T, Deutsche Telekom, Cisco, and so on. They are also developing various products in this domain. And then there are almost every week, when I look at those sites like Kickstarter, Indiegogo, and so on, you see almost every week a new crowd-funded project that deals with smart home, one way or another. Like, be it bulbs from LIFX, SmartThings, the heating system from Tado, or here Pipesbox, Germany, a German company, actually using OSGi also. So you really find everything every week something new. And then there's also a lot of venture capital coming into the smart home business. So LIFX, Tado, SmartThings, they all got a lot of venture capital and try to establish a business around it. SmartThings was just recently bought by Samsung, $200 million acquisition. Revolve was bought by Google just, I don't know whether it was last week, but very recent. They discontinued the product and just bought the people basically for them, for their own developments. And then there is this famous Internet of Things landscape that basically shows all the major platforms and building blocks and applications, not just in smart home, but in IoT in general. And the problem with this is, just a second, that the most of this is proprietary technology. The use of standards is in general limited to protocols like ZigBee, Z-Wave, and so on. So they just really use them to connect to devices and to build applications around it. Expandability, if possible at all, is usually restricted to one vendor. There are also limited upgrade capabilities. So I mean, additional functionality that you might find useful may never be available. And in some of the cases, there is even no tooling available in order to build new applications around it. And at the moment, all these activities actually are independent of what the telcos currently are doing, or also cable cos. They are also themselves developing smart home systems a lot. Deutsche Telekom has this KibiCon initiative. AT&T has Digital Life, and there are many others. But all those, let's say, systems can or are likely not to be integrated in such an environment. Also because they don't provide the necessary interfaces. So then there's limited functionality. So many of those Kickstarter projects or products that come out of this, they have a single purpose, or at least a very limited set of functionalities. And they're mostly controllable on a smartphone or a tablet UI. So before you start, or before somebody wants to get started to develop their own smart home system, there should be a couple of considerations. First of all, there is no single killer application. All these apps that have a single purpose, they will have an end. Yeah. May not be now, but in a couple of years, and then the business will crash basically. And then sustainable business, in my opinion, can only be generated when there is a developer ecosystem around it, and especially Apple and Google have proven that this works. Yeah, I think I don't need to explain this. Then there is a jungle of standards and technologies, so making the right choice is really crucial. And we from OSGi and also from Process especially have done, let's say, some experiences, of course, in the area. And there is, for example, this HGI open platform document that I will explain a little bit later. And there is the OSGi device abstraction layer that plays an important role there. And then those companies should think about where the functionality should be located. What should be in the cloud, what should be in the home gateway. And in general, for me, especially when it's about telcos, smart home is just the beginning. So you could think of e-health applications and many more useful features. So we try to follow a standards-based approach. Process is, of course, very active, especially in the OSGi Alliance, but also in HGI. And we do follow, when we are not active, other standards like ETSI, 1M2M, Broadband Forum, and then all those, let's say, standards that define the communication protocols. So we really try to use, where possible, the standards approach. So two components or two things I want to explain a little bit here is the HGI Open Platform 2.0, which is a successor of the specs document. So HGI, just as a, let's say, a little note, is an organization that was founded by major broadband service providers like Deutsche Telekom, France Telecom, and so on, and also equipment vendors. And they have defined requirements for software execution environments in home gateways. And they define generic requirements that are technology independent. That's about reliability, security, lifecycle management, remote management, and so on. And they have also a couple of OSGi specific requirements. So, requirements specific to the JRE and requirements specific to OSGi. So what kind of services should be used, how they should be configured. So the use of DMT admin, event admin, and so on. There will be a I think tomorrow, a presentation from Andreas Kraft, who explaining a little bit more about the activities of AGI. That's very important, and the good thing is that OSGi plays an important role here. They, as I said, have these generic requirements, and they have OSGi-specific requirements, but besides OSGi, I don't know any other open platform compliant solutions yet. Then there's the device abstraction layer. The device abstraction layer is supposed to be an API that is applicable for all relevant protocols. Provides a generic device data model. It allows to perform device operations. It provides access control based on user and application permissions. You have a very fine-grained security model, and you can benefit from the flexibility of the OSGi security model. And then it also provides notifications for changes in the device state, in changes in the device data model, or in, let's say, changes in the operations. And the device abstraction layer is actually very important because it solves a common problem for developers. Developers that want to develop smart home services don't have to deal with protocol-specific behavior. They don't have to go into the detail of ZigBee, Bluetooth, Z-Wave, and whatever there exist. They just make an application that talks to a light bulb or talks to a washing machine and deal with the device, but not with a protocol. Then there is no need to make workarounds. There's no need to make a custom device abstraction, and it's also avoiding uncontrolled dependencies. So because many applications may use different devices, and there are dependencies that just cannot be managed anymore, depending on how complex the system obviously is. And then there's obviously more that needs to be considered. So this is, let's say, a kind of high-level reference architecture. So we have here the home gateway with the OSGi framework. We have here a couple of devices that can be connected via the different protocols. So here we have obviously then the device abstraction layer and so on. And then you need to provide some kind of user interaction via mobile tablets, PCs, or TVs, or whatever. And then you need to have, of course, an environment that provides application developers the possibility to basically submit applications and then to make it available via a general or centralized application store. And then there's a remote management system that delivers basically those applications to the home gateways, that monitors whether everything is working, and that can do troubleshooting and stuff like this. So this slide is just to make sure, or to demonstrate that such an environment allows business model enabling. So you have here the gateway, you have the OSGi environment, you have the different, let's say, technologies. You have, all these OSGi features about security, remote management, and the update mechanism. You have the device abstraction layer. We at Process have on top a home automation manager where we can define scenes, rules, conditions, so that if somebody has a motion detector and it detects that he enters the room, that the light turns on, or the heating starts, whatever. And then we have APIs that make it available to apps either locally or remote. Here we have the App Store. So from here, the service provider, the carrier, the ISP, they can define the business model for the specific services and makes them available to the gateway, basically. So potential sources of income. So as I said, this was, to business enablement, and this allows to do different things basically. So a service provider could get money for the base system. He could make revenue on additional equipment like motion sensors and stuff like this. He, let's say, can make revenue by selling apps and services, and there can be different models for doing this, depending also on what kind of app it is. So it could be once per download, it could be a monthly fee or per usage fee, or a combination of them. Then there is a possibility to make revenue also from and with the developers. The least likely scenario is that the provider is selling the SDK, but he can also provide it as part of a developer program where he may have something like an entrance fee or yearly fees, a certification process before apps can actually can be made available in the application store, and then there is a revenue share for apps and services. So like what Apple and Google do, for example. So I know this is, let's say, a very open source minded community here, but these are, let's say, experiences that we made with many of our customers. These are usually companies, either telcos or gateway providers and so on. And before I start going through this, I think I should say that this community usually is very conservative, is very secretive, yeah. So they don't have necessarily experience with open source, and there's a lot of reservation for it, besides the point that we want to sell our software. But so the thing is that many people, think if they use open source that there are no costs. So I mean, there's no license fee, yeah, but there are still, let's say, costs coming up to use it. So this may be missing functionalities that need to be implemented one way or another. Usually, this open source middlewares in this case are not fully optimized for the use in embedded systems. So there are many mechanisms that are just not available, like resource management and so on. Then there are issues about liabilities. There are even certain companies, especially from the United States, that I'm aware of that have even rules to not use open source software in their companies, basically, because they are afraid of patent issues, IPR issues that may come up. Then there is, let's say, then there are other potential legal issues regarding open source, because you cannot just, let's say, combine different open source projects, put it together and deliver it out. So some of the licenses just don't allow this. And then when you are in the position of somebody that, let's say, wants to develop a smart home system, they may have limited control over the direction of the development in the project. So this may just, not go in the direction they are planning it, or they would like to have it. And then, if you put it all together, the investment might be actually higher than licensing basically ready-to-use commercial software. So these are, again, just, let's say, experiences from customers that we made. Proprietary solutions will end up basically there. As I said, maybe not in the beginning, yeah. So there, if you look like how many different connected lamps there are now. There is LIFX, there is Philips Hue, there is GE now, there is I don't know what, yeah. There will be 2 or 3 that will, let's say, survive this. All the rest will end up there. There are a couple of examples using OSGi. There is, for example, KiwiCon from Deutsche Telekom. KiwiCon is a, let's say, a B2B product, if you want. So they have a partner network, companies like EnBW, Miele, Samsung, and so on. And those partners can take basically the KiwiCon home gateway, yeah, make the apps on top of it and sell it to their own customers. So they don't have to basically deal with the development of the hardware. They don't have to deal with the basic software infrastructure, if you want. Yeah, that's all coming from Deutsche Telekom or from KiwiCon. And they have not just the home gateway. They have an SDK that is provided. They have a portal and a shop where customers can buy new services and even the equipment. They have the backend, and they provide also the operation and support for those partners. Partnership is growing, so they actually got recently a lot of new partners. This is just an overview of some of them. I've seen there are a few more that I haven't been aware of. And Deutsche Telekom obviously wants to sell this also in other countries. So here are a few examples based on KiwiCon. So there is the Deutsche Telekom Smart Home product. There is, I think this is EnBW. They have like a energy management system based on KiwiCon. Something similar from Vattenfall, another utility company. And then there is a service called Smart Home Allianz Assist, which is like a combination. You get the box and you pay a monthly fee, and you are insured, for example, in case your washing machine leaks. Yeah. So some really new innovative services. AT&T in the US also has an OSGi-based home gateway. It's called Digital Life, and they have packages. So they have a security package, they have a door package, they have a water package. So different kinds of packages where you buy the gateway, the equipment, and you pay a monthly fee for the service. And this actually is selling very, very successful in the United States. And one of the more recent or very recent examples is Velu Home Control. So Velu introduced this in September at the IFA in Berlin. And this is also an OSGi-based smart home system with lots of different equipment around it, motion sensors, thermostats, smart plugs, cameras, and so on. And they have a very nice user interface around it. It's really pretty cool, and they will sell this in the retail channel and also make it available as an OEM version to other potential customers. They have dealt also a lot with how to integrate, for example, all those different devices, and you make use of for example, the device abstraction layer, and also for example, in the case of Deutsche Telekom, it's HGI compliant. So the architecture is in general the same. There are maybe detailed differences, but the general architecture is the same. Okay, I'm basically done. If you have any questions. Anyone who wants to start developing smart home system services? Okay.
How about a scenario where you want to install an OSGi bundle, like an app, and
Yeah, so I can only say how we deal with it at Process. I mean, we have this management system, and this management system, let's say, as well as the framework, obviously, work with certificates. Yeah, so.
Okay, let's assume you trust that the bundle really comes from the developer who claims to have developed it, but let's say you trust the bundle, trust the app to switch on and off your light, but you do not trust the app to unlock the door of your house.
Mm-hmm.
So can you, I don't know, let's say use security measurements?
Yes, yes, definitely. So I mean, this is, the device abstraction layer is designed in such a way that you have, as I said, fine-grained permissions. So you can give an app permissions to do this and not permissions to do, to lock the door, for example, like you said, yes. Please?
Could you elaborate on how this relates or what your opinion is about the Open Hub project?
I mean, it's partly the same, but there are differences, obviously. So what I was saying now is based on, let's say, activities that are in the OSGi alliance. Basically, this device abstraction layer is a specification that we are currently working on and is like almost complete. Yeah, and there is probably the biggest difference because Open Hub has this, I think they call it smart items. Yeah, which is something different. Yeah. So they have a different mechanism. I'm not sure whether they, will switch, when the specification is ready to a device abstraction layer. I can say, but there are definitely some differences, and I don't think that Open Hub is, for example, HCI compliant as of now, at least. But this may change as well. So, any other questions? At the moment, I would say for homes, for residential homes, but there are also activities for buildings. But so we at Process and let's say also systems that I'm aware of, are mostly used for residential gateways, not for big buildings or anything. We have also examples there. For example, the Cologne Tower in Köln. It's a big building that's controlled by one OSGi framework, and they control all the lights, the blinds, and everything, from this building. But yeah, again, the residential is the driving force, actually.
Any other questions?
When you build the device abstraction layers, how do you deal with devices that do not fit into the abstraction?
I mean, as of now, we only define the device abstraction layer, basically the infrastructure, if you want. We have another RFC that defines some basic functions of like binary control, multi-level control, and so on. But there are other activities going on in, for example, the home HCI it's called now. So they currently define a template, a device template, if you want, that they are planning to send to all those other standards bodies, and hope that they, fill it out, send it back, and then there will be, a generalized, version of it. So they try to make it, as broad as possible. But the device abstraction layer obviously is not limited to this. Yeah, it could be extended by, defining your own functions and so on. So, anything else?
Okay, then first of all, thank you very much.
Thank you.